Okay, so what we've got here is 3 to the second power and then 3x raised to the third power. I'm going to expand this out just so you can see this. This looks like 3 times 3, that's 3 to the second. And then what we're going to do is 3x 3 times. So I'm going to write that like this, times 3x, or 3 times x, times 3x, or 3 times x, times 3x, or 3 times x. That's essentially what we've got. Here is our 1, 2, 3 times that we're multiplying 3x. That's this. And here is our 3 times 3. So we ended up with how many 3's are we multiplying together? We're multiplying 5 3's together. So we could write that as 3 to the 5th times, how many x's do we multiply together? 3, x cubed. Now we can do 3 to the 5th. We can multiply that out. And I'm going to write it over here, 3 times 3 times 3 times 3 times 3. And just do this. I'm going to pair these up and get 9. Pair these up and get 9. I'm going to multiply that times 3. What's 9 times 9? 81. 81 times 3 is 243. So we get as a final answer 243 x cubed. Okay. The next one, we've got the same base, 4.1, on both of these terms. One of them is raised to the 5th power, one of them is raised to the negative 5th power. What do we do with these? We add the exponents together. If we added the exponents, we would get 4.1 raised to the 5 plus negative 5 is 0. And anything to the 0 power, including 4.1 to the 0 power, equals 1. So we get as an answer 1. And over here, oops. Finally, we get b to the 6th cubed. And when we have powers raised to powers, what we do is we multiply them. We got to do this first bit first. And we multiply the 1/6 times 3. We get b to the 3/6, or b to the 1/2. And that's times b to the 1/6. When we're simply multiplying, not raising powers to powers, but just multiplying, we have to add the exponents. So we get b raised to the 1/2 plus 1/6. Or another way to write that is b to the 3/6 plus 1/6, which is the same as writing down here below b to the 4/6, because 3/6 and 1/6 is 4/6. And that exponent simplifies to b to the 2/3. And then that's what we get as our final answer. All right, for 56, you can see that these two amounts are being added together. This amount is being added together with this amount, and so we need to resolve them first and see if we're able to actually add them. So let's get these marks out of here. We're going to distribute the squared to every term inside this first parentheses. So we're going to essentially get parentheses -5 squared times x squared. Okay. We'll eventually add to that plus 5x squared. Now, what is -5 squared? That's -5 times -5. Negative times negative is positive. So we get 25. And what is x? When you square it, it's x squared. So we get 25x squared plus 5x squared. Now, because we're adding, we're just saying, do we have the same terms? We do have the same terms. We have an x squared term here and an x squared term here. Those are the same thing. If you have the same variable raised to the same power, that is a like term. So we have this like term and this like term. And specifically, how many of them do we have? We have 25 of them here and another 5 of them here for a total of 30. 25 plus 5 is 30. And what are they? They are x squared terms. So 30x squared. That's what that one equals. And the trick there was you had to resolve this first term first, distribute that exponent through, and simplify it. All right, we're going to do the same thing with these. We're going to, before we can, notice this, in here, in between here and here, between those two terms that are each individually being raised to the third power, there's multiplication. So we need to raise something to the exponent before we multiply. That's order of operations says do exponents before. So then what that means is that we need to actually resolve these two pieces separately. Okay, so um, let's do this one in purple. Let's do this one in blue. Um, if we were to multiply, if we were to do this one in purple, we're essentially saying we're going to give that to the third power that's on the outside to each piece on the inside. And what are the pieces? Well, the pieces are -2, put parentheses around that, raise that to the third power, times a to the 2/3. We're going to raise that to the third power, and b, raise that to the third power. Okay, then we'll multiply that by what we're going to do here in light blue. We'll take that a term, raise it to the third power, times we'll take that b to the 1/3, raise it to the third power. Okay, each bit gets that exponent. Now how do we resolve this? Well, -2 to the third power is -2 times -2, which is +4 times -2, -8. Okay, whenever you have an odd exponent and the base is negative that you're multiplying multiple times, an odd number means you're going to get one extra negative left over. Every pair of negatives will make positive. If there's an extra one because it's odd, it will be a negative. So we've got a -8. Okay, what do we do with the exponents when you raise a power to a power? You multiply them. And I'm just going to do this down here and then erase it. If you multiplied 2/3 times 3, that's what you're doing here. Okay, 2/3 times 3. If you're doing that here, then multiplying across, essentially you should be able to see this as, oh, those 3's cancel. So you could multiply, if you didn't cancel, you could multiply through and say, oh, that's 6/3, and then simplifies to 2. But if you did do that canceling, then you'd see that it's just the 2. That's what's left. Okay, so you get a to the second for this. A to the second. Let me erase all this junk. And then b to the third, because the b is just the b to the first, right? And when you multiply the exponent of 1 times the exponent of 3, you get that. So that's what you get there, times, and here you can see a raised to the third power is just a to the third, times b to the, and again, you're multiplying the exponents, so what's 1/3 times 3? We can do it down on the bottom here, 1/3 times 3, and again, you could multiply across and say 3/3, which equals 1, or you could just say those 3's cancel out, leaving you just 1. Either way, it's b to the first power. And since we don't write to the first power, we just write the base itself. We then get b. So we've got 8a² b cubed times a cubed b. Now, we still need to multiply them together. And how do we do that then? We say, okay, the coefficient of -8, this has a coefficient of 1, so -1 or -8 times 1 is just -8. Then here we've got a² and a cubed. And whenever you're just straight multiplying, you're not raising a power to a power like you're doing up here, but you're just straight multiplying a² times a cubed. You add those exponents together, so you get a to the 2 plus 3, or a to the 5th. And then finally, you have b cubed here, and another b. This is b to the first. You won't see that to the first power, but that's what it is. So b cubed times b to the first, again, is then b to the 3 plus 1, or b to the 4th. And that is what you get. Great, love it. And let's continue on. We're going to do the same thing here. We're going to square, distribute both exponents that are outside the parentheses into the parentheses before we multiply. Remember, there's multiplication going on in between here. And the first thing we need to do is we need to deal with the exponents before we can do any multiplication. Okay, so I'm going to do the same thing here. I'm going to do purple first and then blue. And we then say, okay, that's like 2 squared times x to the negative 3 squared times 0.2 squared times x squared. Okay? Excuse me. So let's resolve this. 2 squared is 4 times x to the negative 3 squared. Remember, power of a power, we multiply those numbers, we get x to the negative 6 times 0.2 times 0.2, I happen to know is 0.04, because 2 times 2 is 4, and there's 2 decimal places then. And then, of course, the x raised to the second power is x squared. Now, because we're multiplying these together, we're going to multiply the 4 times the 0.04, and we get 4 times 4 is 16 with 2 decimal places, so 0.16. X to the negative 6, right here, times x squared. Remember, when we're just straight multiplying those two together, we add the exponents together, so we get x to the negative 4. And if we were to then resolve that by moving the x's down to the bottom, because there's a negative exponent on it, we would get 0.16 over x to the 4th. Okay. I did all these. I did not check them against the answers in the book. I just solved them. I'm going to let you check and see whether I'm right. So if you have my answers and you check it off here, you shouldn't really be checking yours against mine. You should check it in against the book. And, in case you catch me making a mistake, you can call me on it. But I think I did it right. Okay. I love this problem. Here's what we need to look at for this problem. It's actually quite more simple than you think. It looks like a scary number, but let's do it. We've got this right here, 0 to the 4th power. That means 0 times 0 times 0 times 0. And what is 0 times 0 times 0 times 0? It is 0. And what is anything times 0? Because all of this is being multiplied together. You've got essentially what you've got here, if we were to write it out, is 4 times x times y times 0 times 0 times 0 times 0 times, and you can see how that's y to the negative third. That's the same as times 1 over negative y raised to the third. Or you could say that's negative y times negative y times negative y. But essentially, all of those other things don't matter, because here you are multiplying by 0. And what does it result in when you multiply by 0? You get 0. So the answer is 0. Wow, that was easier than we thought. Okay. Okay, what do we got here? Well, let's deal with this separately in two pieces. We're going to say 10 to the third raised to the 4th power. Anytime you have power of a power, you multiply these numbers to find out how many. Basically, it's 10 to the third times 10 to the third times 10 to the third times 10 to the third. This 4 here says multiply this together with itself 4 times. So you end up with 10 to the 12th power, okay? And then all of that times 4.3 times 10 to the negative 8. Okay, so what we can do here is we can say, let's say this, times 4.3 times, and then 10 to the negative 8 is the same as 1 over 10 to the 8th. Okay? Or really, let's actually just keep it as 10 to the negative 8, because then we can say, if we say that, we say times 10 to the negative 8. We're going to take things with the same base. We're going to take this and this because they've got the same base. And we're going to multiply them together. Let me write equals and then write the 4.3 that we've got. 4.3 times 10 to the, and remember, if we're multiplying these two values together, 10 to the 12th and 10 to the negative 8th, we add the exponents, and when we do 12 plus negative 8, 12 plus negative 8 is 4. And now we've got 4.3 times 10 to the 4th, and essentially what happens when you multiply by 10 is you move the decimal to the right every time you multiply by 10. So we're multiplying by 10 4 times, so we could write 4.3 and then just add zeros at the end, right? Give them something to move past, and then say, okay, if we're multiplying by 10 to the 4th, that means we've got to move the decimal 1, 2, 3, 4 times so that it ends up there. And what do we get? We get 43,000. Okay. Final one. Let's do these in pieces. Since they're being raised to powers, we're going to say, let's do this separately from this and examine the results and multiply the results together. So we've got to do the powers first. So 3 to the 7th raised to the 2nd, that is 3 to the 14th. We're going to multiply that by 3 to the negative 4 raised to the 3rd. Again, when you raise power to a power, you will multiply those exponents, so we get 3 to the negative 12. Okay? And now what we've got is we've just got two exponent terms with the same base being multiplied together. So what we're going to do is we're going to keep that base and we're going to add the exponents. And when we add the exponents, 14 and negative 12, we get 2. So we're essentially, all of this becomes 3 to the 2nd power. And we can resolve 3 to the 2nd power to be 9. And that is the answer. So there you are, all three of them done.